Hello students, welcome to our channel. In this channel we will be discussing physics of NEET and JEE mains. Okay, so 11th physics and 12th physics together we will be discussing 200 important topics for the NEET and JEE. Okay, so if you see the 11th physics there are approximately 15 chapters and also 12th physics there will be again 15 chapters. Okay, so total 30 chapters. From overall 30 chapters we will be having 200 important topics. Those 200 important topics, if you master, if you know how to solve the problems, definitely you will be getting minimum 140 marks in the NEET exam and very good rank in the JEE also. Today's topic we are going to discuss the prism. Okay, so that's for dispersion and dispersion through the prism, right? So let us take the heading here, prism. So before going to discuss what is prism, right, I have to explain first what are the types of medium as far as the optical properties are considered. Okay, generally there are two types. First one is dispersive medium, another one is non-dispersive medium. Okay, so what is dispersive medium? If you ask me, the medium which offers the various refractive indices for the various wavelengths. I mean, unequal refractive indices will be there for the different wavelengths. For example, lambda for red and lambda for violet. Wavelength for red color and violet color, they are not same. Generally red color has more wavelength than the violet color. So accordingly refractive index of red color will be less than the refractive index of violet color. Because of the property, the refractive index is inversely proportional to the wavelength of the color. Okay, so as a result what happens, the velocity of red color will be less than the velocity of violet color. Velocity of red color will be greater than the velocity of the violet color because of the fact red color has least refractive index. Okay, you all know that the velocity is inversely proportional to refractive index of the medium. Okay, so if more the refractive index is there, then less speed will be there. Okay, so from this we can say like classification of medium, if you consider there are two types. I told you already, one is dispersive, another is non-dispersive. What is dispersive medium? I told you just now, that is a medium which offers the various refractive indices for the various colors, okay, or various wavelengths. But if there is another medium which is offering same refractive index for all colors, I mean all wavelengths, like air, if you consider, air is a non-dispersive medium. In the air, all wavelengths will be moving with the same speed, that is equals to 3 into 10 to the power of 8 meters per second. I hope you got my point. Okay, so let us classify first what is medium. Okay, optically what is medium, and then we will enter into the prism. Okay, so medium, we will have here non-dispersive medium, and then dispersive medium. Okay, non-dispersive medium, refractive index of the color is independent of the light, I mean wavelength, I'm sorry. The refractive index of the light is independent of the wavelength. That means refractive index for violet color, refractive index for yellow and also red, all are equal, so that velocity of velocity of yellow and velocity of red, all are equal. All the wavelengths will travel with the same speed. That is what actually non-dispersive medium. Example is air. Okay, coming to the dispersive medium. In the dispersive medium, the refractive index is a function of lambda. Okay, that I have to take, it is a function of lambda, f of lambda. Okay, so some function of lambda, right? So based on the lambda, the refractive index will be there. What is the relation here? The refractive index is inversely proportional to wavelength. That means if you consider the VIBGYOR, that is what, violet to the red, violet has least wavelength, so violet will have more refractive index, then yellow, then it is red. So this is the decreasing order of the refractive indices of the violet, yellow and red. Okay, and corresponding wavelengths, if you consider, lambda for wavelength is less than lambda for yellow, is less than lambda for red. Okay, so we are here. Example for dispersive medium is the prism. Okay, so we are going to have the prism case, and also we will have the dispersion through the thin prisms, right? So let us enter into the prism topic. Okay. So physically the prism is just a pyramidal shape. Okay, in 3D it will be a pyramid, but in 2D it is a triangle. Okay, so since we can't draw the 3D on the board, okay, so we have to draw the 2D only here. Of course we can draw the 3D, but I don't know how to draw the 3D. Okay, yeah, this is the angle of prism we call. This is vertex A, B and C, right? So if you consider the medium in which the prism is placed, the medium refractive index is mu m, prism's refractive index is mu p. Okay, so if you consider a light is incident here, and definitely here the normal drawn at the point of incidence is this. Always we have to deal with the normals here, because ray optics is a study where the geometry is used. Okay, this is also called as geometrical optics. Okay, so from here it is going from rarer to denser medium, so definitely from actual path it should deviate. Okay, it is deviated, and this is going to be angle of incidence, and this is going to be angle of refraction, small r1, and here it will incident from prism to medium, which is going from denser to rarer. Here mu p is greater than mu m. Okay, so here it is incidenting, then here also you should draw the normal. I have drawn here, and this is going to be angle of incidence r2. Actual path of the light ray is this, but it will be going from denser to rarer, no, so it should deviate away from the path. Okay, so it will be deviating. So this angle we call it as angle of emergence. I hope you got it. Okay, so angle of incidence, angle of refraction, angle of incidence, angle of emergence. Okay, so if I take that, this is P, Q, R and S. PQ is the incident ray, QR is the refracted ray, RS is going to be the emergent ray. Okay, the faces A and B, like AB face and AC face, are called as refracting surfaces of the prism. Okay, the angle between the AB and AC is going to be angle of prism A. This is what angle of prism A. And now we have to apply Snell law here, because for refraction only one law we know already, that is what, Snell law. So of course there are two laws of refractions. Okay, refraction. First law is Snell law, second law is going to be the coplanarity of three rays. Okay, that we don't discuss here. So if I apply the Snell law, it's very simple. Mu m into sin I equals to mu p into sin r1, and I can rewrite this sin I equals to mu p by mu m into sin r1. Let it be equation number 1. And here from prism to air or medium, if you consider the Snell law again, it is mu p into sin r2 equals to mu m into sin E, and I can rearrange this sin E equals to mu p divided by mu m into sin r2. So if I have the notation, the prism refractive index by medium refractive index as mu, then I can rewrite these equations 1 and 2 as sin I equals to mu sin r1, okay, and sin E equals to mu sin r2. Okay, these are the two important equations in the prism we will use always. Okay, but most of the books, what they will give, here mu they will take simply, and they will consider by default the prism in the air. Okay, but if it is not in air, suppose it is liquid of refractive index some value, then the formula will not be applicable. Here this formula you have to use. Okay, so this is a general case I am discussing here. And one more thing, this is two equations you got, and from the geometry we can have from the A to Q and Q to this, let it be Q prime, A Q, Q prime, R and A, that is a quadrilateral. Okay, A Q, Q prime, R A. Okay, the sum of the angles in this must be equals to 360, and I can say this angle is going to be 90 degree because it is normal. So 90 degrees plus this angle, let it be x. So x plus again this is going to be 90 plus again this will be a, should be equals to 360. Then I can rearrange this, you know, x plus a equals to 360. This is equation number, sorry, x plus a is not equals to 360, it is 180. Okay. It is equation number 3. And what is x we need to find, and I can take the triangle q prime r. Okay, in the triangle q prime r, r1 plus x plus r2 should be equals to 180, because sum of the angles in a triangle is 180 degrees. So comparing the 3 and 4 equations, these two, I can conclude that r1 plus r2 equals to a. This is the fourth equation we can have. It's very important. Okay, so instead of having 1 and 2, 3 and 4. Okay, and mostly we will use these only. So these are important equations we can use. Okay, so now let us enter into the next step, that is deviation, because we need to find the deviation suffered by the ray. Okay, definitely at each refraction there will be some deviation. Here there are two refractions. First one from at the refraction of A to B, like AB interface, that is from medium to prism, and second from prism to medium. Okay, so the refraction, first refraction the deviation say delta 1, second refraction the deviation is delta 2, then the total deviation is going to be delta 1 plus delta 2. Okay, and general formula here, deviation is going to be the total. If you apply here the delta 1 plus delta 2, you will get I plus E minus A. This is one more important equation. Say this is fifth equation. Okay, so using all this we can solve any problem regarding the prism. Okay, I hope you got it. So let us list out the equations what I just derived here. So equation sin I equals to mu sin R1, next sin E equals to mu sin R2, and then R1 plus R2 equals to A, and the delta equals to I plus E minus A. The A is also called as angle of prism. Okay, so these four equations you have to remember, and you can solve any problem easily, right? So let us discuss the special cases here. The special cases are, there will be condition for minimum deviation and also maximum deviation, condition for total internal reflection, condition for no emergence. There are many cases. Okay, so we'll discuss everything, right? So condition for maximum deviation, if you discuss first, the deviation equals to I plus E minus A. Okay, so condition for maximum deviation. Okay, so the deviation is maximum if the angle of emergence is 90 degrees. Okay, because anyway angle of prism is going to be fixed for a given prism, angle of emergence and angle of incidence. Okay, out of these two, any one is maximum, then deviation is going to be maximum, and that too incident angle, if it is maximum, that is 90 degrees, then the deviation will be maximum. So if angle of incidence is equals to 90 degrees, then the deviation maximum will be taking place, that is equals to pi by 2 plus E minus A. How much this E, that we need to find here. Okay, for that I am going to write the first equation, this one. Okay, so sin 90 equals to mu sin R1, but if angle of incidence is 90 degrees, then corresponding R1 is going to be C. What is C here? Critical angle. What is C? Critical angle for the given medium. Okay, and regarding the critical angle we will be discussing in the total internal reflection. For that another video I have already created, I will post it. If angle of incidence is 90 degrees, then critical angle will be there, R1. Okay, so corresponding refracting angle is going to be critical angle. Okay, so R1 plus R2 equals to A, then we can say R2 equals to A minus R1, but R1 equals to C, so A minus C. Then from there, from the second equation, we can have sin E equals to mu sin R2, but R2 I can substitute as A minus C. I'll get sin E equals to mu sin A minus C. Okay. So from here I can write for the E equation that E equals to sin inverse of mu sin A minus C. Okay, and substituting this E in the deviation formula, the delta maximum equals to pi by 2 plus this equation minus A. That is going to be, if you spell it completely, that delta maximum equals to pi by 2 plus sin inverse of mu sin A minus C minus A. Okay, so that is going to be delta maximum. This is case 1. Case 2 also will be there, that is minimum deviation. Case 3 will be total internal reflection, and then next case will be no emergence. Okay, and then silvering one phase. There will be many cases, many possibilities in the prism. Okay.